Angular velocity is given by omega. This is a symbol. There is a relation V equal to R omega. This relates it with the linear and translation motion. Angular momentum is given by L, which is L equal to R into P. P is the momentum, and these are the units. Torque is given by tau, which is R into F, position vector or distance vector with the force. Moment of inertia is given by sigma mi ri square, and the regular shapes have proper moment of inertia. There is an analogy between linear motion and rotational motion. Linear motion is this one, rotational motion is this one. So what is the analogy between these two? So what you have to do here is you have to consider that the distance here S is equivalent to, distance or displacement is equivalent to the angle or angular displacement. The linear velocity V is given by ds by dt, so here omega will be given by d theta by dt, which is angular velocity. Linear acceleration is the double differentiation of the distance, or you can say dv by dt, because V is actually ds by dt. So acceleration is double differentiation of d2s by dt square. And what is S equivalent here is theta. So alpha is the angular acceleration given by d omega by dt, which is equal to d2 theta by dt square. The mass equivalent in the rotational term is moment of inertia. Linear momentum is P equal to mv, and in this case we have angular momentum, which is given by I omega. Force is equal to mass into acceleration. In this, torque will be equal to I into alpha. I is moment of inertia, alpha is the angular acceleration. Force is given by dp by dt, and here torque is given by dl by dt. So here force is the rate of change of momentum, the torque is the rate of change of the angular momentum. Kinetic energy is half mv square, which is given by p square by 2m if you use momentum. In this case, the rotational kinetic energy is equal to half I omega square. If you take the angular momentum given by, this equation becomes L square by 2I. The work done is given by F into S. The work done here in this case, in the rotational motion, it will be tau theta. Power is F into velocity, force into velocity, it will be tau, means torque into angular velocity. The linear momentum of a system will be conserved when no external force acts on a system. This is principle of conservation of linear momentum. And what does this principle of conservation of angular momentum says? Angular momentum of a system is conserved when no external torque acts on the system. Here we have the translation motion equation. What you have to do here is, this is initial velocity. So you have to take u as omega 1 here, the v as omega 2 here, and t will remain same. S can be taken as theta, and alpha has to be taken for acceleration. So just these equation becomes these equations. V equal to u plus at, S equal to ut plus half at square, V square equal to u square plus 2s. What is the distance traveled in nth second? Nth will be u plus a by 2, 2n minus 1. In this case, theta nth, that is the angle being traced in nth second, will be omega 1, that is the initial angular velocity, alpha by 2, 2n minus 1. This is plus.